Okay, good morning again and welcome back. And for those of you who are very media savvy, I want to bring to your attention that Epic India is actually live tweeting this. So if you want to know their Twitter handle, it's right there, Epic India. Okay, at epic_India. So if you want to join that and get the word out so that we can have an enlightened citizenry to make sure that we make this as important as it is. What we're going to be doing between now and and tomorrow is to try and really dig deep a little bit into the science and the data to help all of us understand where we are and where we need to go in terms of mitigating some of these challenges. So this next session is going to focus on the issue of household air pollution, climate change, and the indoor environment. And we have an incredible panel of speakers here, ranging from Dr. Suma Nair, who is a professor and head of the Department of Community Medicine at Manipal Academy of Higher Education. We're going to have also Santhosh Chidangil, did I call it right? Who is the head of atomic and molecular physics at Manipal Academy of Higher Education. So we're really trying to learn as much as we can so that we can come up with solutions to this. And then we have Kenneth Lee from Epic India, who's going to who is the executive director of Epic India. And then I'll be on that panel to also talk about some of the solutions that we've tested in Nigeria that's really applicable to some of the issues where people need to transition from unclean to clean cooking indoors. So Dr. Suma Nair is going to be starting us off on this session, and she's going to be talking about ambient and household air pollution-related global burden of disease, a public health perspective. Please join me in welcoming her to the podium and for joining us.
I think a lot of what I have to say was already spoken during the first half. As a community health physician, my area of focus is on community health. And obviously, this is a burning topic which has a lot of impact and implication on that. So I'll just go on a broad overview of what is there and what literature is available. But more importantly, also some of the aspects that we came across with a short collaborative project that we've actually started recently with the University of Chicago and Dr. Pinto in particular. This is, I think, a very familiar scene to a lot of people in Delhi, and not something which we see down south, at least not in Manipal. And like someone pointed out, as we sit discussing this, WHO is having its first global conference on air pollution and related events starting tomorrow. And hopefully there'll be somebody from here who will be discussing these issues there. So a lot of reasons for this very poor air quality that is a hallmark of India in particular. And it's not just about Delhi. I'll just talk about some of the other data that I have, and Bangalore is not really clean either. So probably it's because of the rapid urbanization that happened over the last 2 decades or so, and obviously the increasing industrialization. We were primarily an agrarian society, which is rapidly changing, and I don't think we really know how to go about it. So essentially what happened decades ago, a lot of years ago in the West is what is happening today in India, and probably this is how it would move through. So you have the opening up of the economy, you have increasing industrialization, obviously a lot of big cars coming in, and all these things have actually contributed to the ambient air quality, which has deteriorated over a period of time. But as far as the indoor air pollution is concerned, and this is from what we have at our community level, the clean energy, what we talk about, obviously there has been government initiatives to improve the clean energy procurement, but however, it's far from reality. people still prefer wood fuels, and there are certain reasons for that. And when we talk about a community like the rural Karnataka, where we come from, or where we actually primarily work in, they use the boiled rice, which they actually use as their daily, cereal supplements. That needs a lot of cooking, and it cannot be cooked on your LPG. It takes a lot of time, so there's a lot of LPG that will be consumed. So they prefer to cook it on a wood fuel, so it just getting cooked over a period of time. So invariably, every home that we visit, definitely, even though they may have LPG, they also would supplement it with the wood fuel. So almost 25% of them used primarily wood fuel, but almost 65% had both. So you can see that there are, even though they use the clean fuel, there is wood fuel also being used simultaneously. And as we looked at the smoke outlet availability, only about almost 56% did not have a proper smoke outlet. It may be just a small slit in the kitchen through which they say the smoke goes away, or sometimes there is nothing at all. Sometimes there would be an outlet, or at least a window which they completely close because they feel something will creep in out there. So essentially, that was again a very important component that we actually observed. And besides, of course, ventilation per se was not very good. The poor ventilation was visible in almost 43.86% of the population that we surveyed. And this was based on the criteria that we use for ventilation, etc. Smoking was not primarily an issue, but however, 16% also there was a smoking within the home. So all of these contribute together to the indoor air pollution component, which primarily we saw in a rural setup. And I'm sure a lot of this also can be translated into other parts of the country, if not a little more than what we have. So essentially, obviously, because of all this, we have this as the burden. Almost 1 in 9 deaths worldwide can be attributed to air pollution. And a significant number of this happens in developing countries, and 90% of the world population live in countries with poor air quality. And India actually is a good example of that. Now, the levels of pollution that impact health, I think we did speak about the particles, the less than 10 microns, etc. Yes, these are the recommended averages. When you look at particles less than 10 microns, they actually go and lodge in your lungs and actually cause lung diseases and create all those problems that you have. But we are more interested in those which are less than 2.5 microns, because these actually cross the lung barrier and enter the bloodstream. And this can actually cause most of the non-communicable disease burden that we have, click of a button. So they've actually given us a lot of targets, interim targets for cities. So the target 3 is actually 15 microgram per cubic meter, something which they say it's okay, at least if you reach this. This is actually exposure to this particular component over a 1-year period. But target 1 is about 35 micrograms. But beyond this is really, really not acceptable at any point. And what do we have in our country? Now, these are all from the ambient air pollution document that WHO has brought out. I just looked up, we have this very interesting website wherein you can actually look at the air quality of various cities. Unfortunately, I couldn't look up Manipal. It's not listed, nor Udupi, from where we actually come from, so it's not there. But we did have Bangalore. So I was just looking at this. But I just also, just last week I was in Aberdeen, so I was very keen to know what was their air quality level. And as you can see, I'm not sure if it's clear. Yeah, this is the recommended WHO, 10 micrograms per cubic meter, which is permissible as per WHO, which is rather safe if you're going to be exposed to it over a 1-year period. Aberdeen obviously was much less than that. You could feel it. When you go, it's crisp and it's, the air is so pure. You feel the, freshness all around you. I just looked at Montreal. Yeah, and that again was, in the safe zone. So what do we have in India? What do you think Delhi is? What could it be? Just a guess. Where will you be? Not too bad. Okay, so that's Delhi for you. It's 14.3 times the permissible level. So obviously it's 143. This here. And so Bangalore, someone said, was rather safe. Well, not really. It's almost 4.7 times. Again, it's 47 micrograms per cubic meter, which is not even at the interim tier 3, which actually talks about I think the previous one, it should be much less than 35 micrograms per cubic meter. So we are nowhere near there. So actually, it's a pretty poor situation. And I looked up most of the cities in the country, we have no city which is actually at the permissible level. So though they are talking about comparing with a livable city or probably an okay city to those who are highly polluted, actually we don't really have standards which are comparable as per the WHO guidelines, which is very, very, so much of a concern to all of us here. So what exactly is the impact of this huge problem on global health? There obviously is going to be an indirect impact. As we all know, it produces climate change, and so atmospheric concentrations of greenhouse gases, and thereby leading to Earth's atmosphere, which is going to be much higher than normal. I think we're all experiencing that. Frequent floods, droughts, all these things are a reality, and we are seeing it happening right in front of us. Every month you seem to have a calamity occurring. The direct impact obviously is the rising prevalence or incidence of non-communicable diseases. And yes, we talk about India being the diabetic capital, increasing cancers. All these things are probably in some way also contributed to a lot of things by lifestyle factors. But yeah, air pollution also has a role to play. We don't really have enough data to say how much is contributed. We just have a world data. But I was looking, we don't really have a lot of data from India per se. Though, like the earlier speaker said, there are some studies in the anvil, but we don't really have those documents as of now. So this enormous burden of NCDs, way back in 2005, we saw that communicable diseases was an important area of concern with almost 30%, and cardiovascular disease was around 30%, and all the others followed. By 2011, we find that it's almost the same, but there is a slight shift. And this, of course, the 2011 data. The recent data is probably a little higher than this. So we find a rising incidence. We have both burdens. We are a country with both problems. But progressively, we find the non-communicable disease overtaking the communicable, which is, again, of concern. Not that we are happy that the communicable is coming down. It's a very good scene. But then when you have this thing rising, we're going to have more and more problems coming up in the days to come. So the cardiovascular health in particular, as you can see, because the direct effect due to the air pollutants and, of course, the extremes of temperature, which is, again, a consequence of air pollution in some ways, causes strokes and cardiovascular diseases in terms of ischemic heart disease. And 24% of all strokes or 25% of ischemic heart disease has been attributed to air pollution itself. When you look at respiratory health, you also have, they talked about the farmers putting fire to, their produce, etc. More than bushfires, yeah, we do have those kind of instances. But then rising temperatures also give rise to all these other, environmental issues. And, of course, fine particles, and which, again, is a problem which is inherent to India. And like I mentioned, fossil fuels or wood fuels are something which is being burnt over and over again. So these are things which, again, causes either indoor air pollution, and also on a larger scale, the ambient air quality itself is compromised. And almost 43% of all lung diseases have been attributed directly to air pollution. Cancers, I think this is another area which is of concern. We have a rising cancer incidence, lung cancer for sure. The other cancers, we don't really have a direct data linking them, but this is some area which probably we need to work on and see if this is also having an impact on a lot of other cancers which are rising progressively in India. Mental health, this is another area of concern. We talk about extremes of temperature, which probably is a result of air pollution, and therefore scarcity and competition for resources. And because of these climate change, etc., they are vulnerable. You have huge amount of farmer suicide, which still continue to plague India. And this is, again, an indirect consequence of the air pollution concern. So this is something which is of significant importance to our country. Mental health, though we don't talk about it, but this has a huge impact. And because of all those disastrous calamities that keep happening, that again has a huge amount of survivors there who are deeply affected. For instance, the recent floods that affected Kerala, large number of population lost everything in that. And then the survivors have to live with that for years to come. And that's, again, a huge problem. And again, all this is in some way indirectly related to the pollution levels and the environmental change that is happening along with it. So essentially, obviously, because of all this high NCD burden is a threat to development, as we can see. You have loss of productivity, as we know, because of premature deaths. But more importantly, this is what is important from the point of view of India. It is a study which was done in Kerala. But most of this is so true because most of our healthcare is out-of-pocket expenditure. So I didn't see that. Yeah, I'll be done soon. Most of it is out-of-pocket expenditure, and therefore we have a lot of stress on healthcare requirement, and the inequities in this healthcare is again another cause of concern. This again shows loss of national income due to all these non-communicable disease, which could be a consequence of this. So no wonder in the Sustainable Development Goals put together by UN for a sustainable development in the world, we have a lot of important goals which actually talk about air pollution. One is Goal 3, Goal 7, and 11 are very directly related to air pollution, wherein the indicators are actually about improving clean air, improving proportion of people dying of mortality due to as a consequence of air pollution, and of course the proportion of the ambient air quality in the cities and how much better it has become. So all these are indirect or direct indicators which can actually talk about air pollution as a factor, and whether it's getting improved and whether it's improving the sustainable development on a whole. So what would be the strategies to mitigate? There are a lot of things we can do when we should be doing, and I think that was a very utopian bill that the MP actually proposed. Unfortunately, when he talked about right to clean energy, a lot of our population, I think there's a very interesting question which I think Shreya talked about, the citizen forum. Forget citizen forum. In fact, the large population in our country are very unaware of their basic rights. So when you talk about right to education or right to clean energy, I don't know if they're in a position to understand that they have the rights. So as first and foremost, we have to actually talk to them and say, these are your rights. And then probably they'll stand up and say, yes, don't burn that thing, or maybe I shouldn't do it. So being responsible is very important. It has to come from within. It's a long way to go. But besides that, we have to do all these things in terms of cleaner electricity, reducing the use of fuels. But how do you supplement that? We need to find solutions for that. Improving urban planning, and all these are things which has to be done. But however, from the context of a country like India and how to incorporate in the system, we probably need to have a lot more research carried out, and which could actually translate into practice in the community. And that is probably the way forward. So essentially, these are some of the key messages that I wanted to just pass on. The poor quality, air quality is leading to climate change, and we are obviously seeing an impact in terms of rising NCDs in the country. And this is going to have a huge impact on countries like India, which is burdened with a whole lot of other issues as well. So obviously, improving air quality is of concern and is a priority as far as we are concerned. But maybe as academic institutions, we could take a step forward in trying to bridge this and trying to put across certain ways in which we can bring solutions to the table. And this is how I think we should be looking at it. Yeah, I think I'll stop here. Thank you so much.
Presenter is going to be Dr. Chidangil.
I'm very thankful for this. We, spectroscopy people, will catch a lot of information. Any biochemical changes which is happening at the cellular level can be obtained from analyzing these peaks. And these peaks I was talking about, they are the vibrations of the molecules present in the system. These are all vibrational frequencies. So now, 5 minutes. Now, I was mentioning, I can focus the laser beam on a material. What you are seeing, I am focusing a laser on a material. What you are seeing, the light emitted by the material. We call it just plasma. It is not the blood plasma. This plasma contains information about various elements. For example, trace elements. Biological system, there are many, many elements. You will be able to analyze the trace elements present in it under different health conditions. The level of these trace elements will vary. So you will be able to detect or analyze and quantitatively get information about the materials present in the sample by using this special technique. We call it as laser-induced breakdown spectroscopy. This is the instrument which we developed in the laboratory, and this we have developed for Atomic Energy Agency. So they wanted to detect the radioactive materials which is present in the waste which they are going to dump it somewhere else. They wanted to make sure that the waste is not having any radiological materials. So they cannot take it. They have to monitor it from a distance. So this is a instrument which can detect, you can monitor remotely. So this is the kind of signature which you get it. The very, very, very congested signature of atoms and ions present in the sample. When you take the spectrum of air, break down air, that also contains a lot of lines which will give you the composition of the elements, oxygen, nitrogen, all elements and molecules present in the room. So these are all some of the standard calibration graph for the quantitative analysis of the elements. And this is an instrument for the remote monitoring. And of course, we will use the same instrument. We have proven that this instrument can also be used for the sorting of plastic wastes. You know, we have a lot of plastics. Many of the plastics are very bad. So you will be able to analyze the quality of the plastics, quality measurement or quality checking of plastics, you know, by using the technique which I mentioned here, laser-induced breakdown spectroscopy. So again, the very, very congested spectrum, but we know how to analyze it. It is not difficult. Now, these are all I am talking about hard materials and gases. Now you may ask, you have a little bit of water. You wanted to check whether the water is good. We can analyze the water by using the same technique. You focus the laser beam on a flowing water. So water is coming here, liquid flow. I can focus the laser beam. You will break down the water sample and you will get the various elements present in the water sample for the quality measurement. So this is the air lips which I was mentioning. Focus the laser beam wherever you want. It generates plasma. Sample will break. You will get a breakdown of the sample. You get information about nitrogen, oxygen. These are all standard lines. Spectroscopy people knows it. We have a big library. From the library, you will be able to get the information very fast. So this is the So there is a lot of applications. Optical technique has a wide applications, but the power of the spectroscopy techniques are not being tested for this kind of applications.
Our next presenter is going to be Kenneth Lee, and he's going to talk about the Air Quality Life Index, translating particulate pollution concentrations into their impact on lifespans. So I hope we're going to live longer by being in...
On the Air Quality Life Index. So this is a tool that this group of researchers and our team has developed that is meant to complement the AQI to translate concentrations of particulates pollution into their impact on human lifespans. Okay, so let's see. So this is the problem. 5.5 billion people globally live in areas that exceed the WHO standard for clean and safe air. And to communicate the risks on a day-to-day basis, we tend to refer to the AQI, the Air Quality Index. This morning in the panel discussion, this was referred to a number of times, but the AQI tells us how bad the air quality is outside. It uses a color scheme that ranges from green to maroon to tell us which days are good and which ones are very hazardous. Now the issue with the AQI is that it is a composite index that includes concentrations of a variety of different pollutants, and it doesn't really provide any information on to what extent these different levels actually affect your personal health, and what the cost might be for short or long-term exposure. So this is a screenshot I took on my phone this morning when I woke up. So Delhi, it's hazardous today, the AQI. You can see that, this actually is a a combination of many things, including PM2.5, PM10, and some of these other gaseous pollutants. Okay, so the goal of the AQLI, the Air Quality Life Index, is to take the AQI and translate it into something that actually is more relevant to the day-to-day citizen. What effect would a hazardous AQI level have on my life expectancy if I was living in Delhi my entire life? The question that is relevant to many people, and we talked about citizen engagement, is what are the consequences of exposure and how should citizens and policymakers evaluate trade-offs? So this presentation, I'm going to do two things. First, I'm going to talk about a research study that was conducted by our colleagues at EPIC that comes up with a causal estimate of the impact of PM10 on life expectancy. Okay, it's based on a study in China. And then the second part, I'll try to explain to you how we take that estimate from that research study and apply it to global PM2.5 levels to create this tool where you could look at your own district or your city or your country and understand what sustained exposure to your region's average annual levels might have on life, the average life expectancy of people living in that place. Okay, so part one, what is the impact of air pollution on life expectancy? So many have tried to analyze this relationship, but up to recent years, there have been a number of shortcomings in the existing literature. One issue is that many of the studies assessing this relationship have been carried out in developed countries where levels of particulates pollution tend to be much lower. So if we're talking about studies in the US, this may not be relevant to places like China and India. Also, they are observational in nature, so they are simply taking two data sets, running a regression, and looking at the correlation. What we want to know, though, is what happens when pollution increases or decreases? What is the effect on our health? Okay, so what I'll describe to you is a paper by Ebenstein et al., and Michael Greenstone and others. It was published in PNAS last year. It's called New Evidence on the Impact of Sustained Exposure to Air Pollution on Life Expectancy from China's Huai River Policy. So I'll try to describe this really quickly, and then we'll go to the AQLI. So in China, there was a Huai River winter heating policy, which was established in the 1950s when many policy decisions were taken by the central government. And the idea was to provide free coal to run small boilers for residential heating during the winters to keep households warm to everyone living above the line formed by the Huai River and Qinling mountain range. Okay, so heating was forbidden to the south, but it was actually subsidized to the north. So this is kind of interesting from the perspective of economists because it's a natural experiment. We can't conduct a study where we manipulate pollution that one group experiences so that we could just compare what happens to their mortality in comparison to a control group. So this is great. It's a natural experiment. And what the authors do is they study this GPS data. So this is the line created by the Huai River and the mountain range. And they try to study what pollution levels look like north of the river to pollution levels south of the river and the related differences in mortality. Okay, so in China, the standard way to heat your home is, I guess in these areas, is to use coal to heat water, and that heats up the boiler, and this, of course, generates high levels of soot and particulate matter. And this map shows sort of average levels of PM10 across China, and you could see clearly that it's much higher north of this river than south. So the authors combined data from a number of sources, health and mortality data from the China Disease Surveillance Point System, as well as the most comprehensive compilation of historical PM10 readings for China. And they bring these data sets together to look for this causal effect. Now, the way that they do it, they use a technique called regression discontinuity design in econometrics. Of course, there are many things that are correlated with both mortality and with pollution, and so it's hard to identify that causal relationship. The basic way this identification strategy works is when you zoom into that area close to the river, right? Just the people living just to the north of the river and the people living just to the south of that river, it becomes possible to assume that the unobservable determinants of mortality and air pollution actually change smoothly over that kind of space. But the only thing that is really different is that in the north of the river, this policy existed where coal was subsidized, right? That is a discontinuous change. And so if you see a difference in mortality rates just north of the river and just south of the river, you can attribute that difference to this policy, right? So that's going to be the causal effect that they estimate. So when they do that, they find a result like this. So this is, on the y-axis, it's micrograms per cubic meter of PM10. And on the x-axis, it's degrees north of the Huai River boundary. And so what this shows is the results of local linear regressions run separately for locations south of the river and north of the river. And what you see is when you zoom into that area just around zero, right above and right below the river, there's a discontinuous jump in the amount of pollution, right? So pollution is 50% higher as soon as you jump across the river because of this policy over the study period. Now, similarly, you could look at mortality rates in the exact same way. So that's mortality, life expectancy in years on the y-axis, and your degrees north of the Huai River boundary on the x-axis once again. And as you zoom into that area just north and just south of the river, there's a sudden discontinuous drop in life expectancy. So this works out to, when you combine these estimates together, it suggests that a 10 microgram increase in PM10 leads to a decrease in your life expectancy of 0.67 years, okay? So that was an estimate that came up from this study, this natural experiment. It's very hard to find rigorously identified estimates of the impact of pollution on life expectancy, but this is probably one of the best ones that we have at the moment. We take this estimate and then try to apply it to the AQLI to construct a way to translate AQI into something that is more meaningful to the typical citizen. Okay, so what they do is they take that estimate of the effect of PM10 on life expectancy, convert that into PM2.5, and then apply that to global PM2.5 levels, high resolution concentrations derived from satellites and other data sources. And they find that globally, average life expectancy is reduced by 1.75 years due to fossil fuel-driven air pollution. Okay, so this doesn't include sea salt or dust. So this is the single greatest threat to human health globally. And they find, and this suggests that the effect on life expectancy of air pollution exceeds that of communicable diseases such as tuberculosis and HIV/AIDS and behavioral killers like cigarettes. In India, the average person lives 4.3 years, or the average person would live 4.3 years longer if the country could reduce its air pollution to the WHO standard of 10 micrograms per cubic meter. So these are quite alarming findings. I'll show you some visuals of this. This is global pollution levels, PM2.5, sort of man-made PM2.5 as viewed from satellite data. And you could see that India and China are, they are the worst places on Earth when it comes to air pollution. And that in India, as we all know, most of it is concentrated to the north, just south of the Himalayan mountain range. Now, if India were able to reduce its PM2.5 to its own national standards, this map here shows you where the largest gains would be in life expectancy. So it's a little bit, it's the same color scheme, so it's a little bit confusing, but here dark means good. Okay, so this here dark is bad, and here dark is good. So the largest gains in life expectancy would be experienced in sort of this northern part of India. This is if they complied with national standards. If they complied with WHO standards, it would sort of the gains would be much more widespread. On average, 4.3 life years saved per person. In Delhi, the number is between 8 and 9 years, and so it's very encouraging to see the MP quote that number in this morning's session. But this is the new tool that's been developed, and I think over the coming weeks, we'll be launching an online version of this where you could look up any district globally to check what the AQLI figures are. So in conclusion, the AQLI is a tool that our colleagues at EPIC have developed to complement the more widely used AQI by translating particulate pollution concentrations into their impact on lifespans. And the concept here is that we want to transform the vocabulary that we use, that the regular citizens use when they talk about air quality. We want them to think not just about the AQI, which is an abstract and complicated index, but to also think about the health effect, because once that happens, the willingness to engage, the willingness to pressure the political system to make changes becomes that much greater. So this is my presentation. If you, for more information, this is the website for the AQLI, and we could, of course, share this with participants at this conference over the coming days. Thank you.
I mean, this has been really an excellent morning. And what I'm going to try to do is, if you look at the challenges related to exposure to air pollution, they might be terrible in India, China, but if you look at the whole of sub-Saharan Africa, it's also a terrible place where exposure and the challenges of infectious diseases actually come together to actually significantly curtail life expectancy. All the things that exposure to household air pollution does. And I've done some studies to look at that. But what I'm going to be sharing with you is just an attempt to figure out what if we could actually mitigate some of these exposures. And, you know, politicians may argue, may not see this as a priority, but I thought it might be important to look at a pregnant cohort, because all these politicians, they have wives, they have daughters, they're going to have grandchildren. So if we could actually focus a study that looks at the impact of this intervention on something that people can relate to, maybe it will make a difference. And because it's a global problem, I'm hoping that it's generalizable to other populations, even though this was done in Nigeria. So that was the motivation for doing this. So what I'm going to do is also briefly talk about the local context, because after all, we're in India, talk about the brief pilot that we did in Nigeria that, you know, set the stage for the randomized control intervention, and then reflect on the policy implications and discuss some of the strategies that we may use for future interventions that may be beneficial, not only in Nigeria, but also globally. 9 out of 10 people all over the world, you know, live in settings where, you know, there is no, they don't meet air quality standards. And you have to also recognize that exposure to air pollution is the number 4 cause of mortality globally. And if you look at India, for example, we've talked about India and then China, okay? If you look at household air pollution in India, it's estimated to account for about 920 deaths every year. These are preventable mortalities. It's not like you develop cancer all of a sudden. It's because a lot of the poor people who can't avoid being exposed to air pollution. And if you look at ambient exposure, it adds another 700,000 mortalities every year. That is just a ridiculous number. And you look at China next door, it's about 910,000 and 800, and these are preventable mortalities if we could just get our act together. And you look in here, you can see that the breakdown of the number of deaths, this is 2013 data. And in 2016, we have, if you look at both indoor and outdoor exposure, you're talking about 7 million premature deaths every year, which if that doesn't catch any politician's attention, I don't know what we would need to do to really catch their attention. I thought it would be nice to also highlight some of the work that some of our colleagues are doing in India. This is work by one of our colleagues in the Tamil area, trying to look at the impact of exposure to particulate matter on pregnancy outcome. I thought I would use this to lead into, and what they realized is for a 10 microgram increase in PM exposure during pregnancy is associated with a 4-gram decrease in birth weight and a 2% increase in the prevalence of low birth weight. And most of us know that low birth weight is associated with a lot of comorbidities and lifelong disability in children. So it's important to start thinking in terms of the next generation, in terms of the impact of the mothers who are being pregnant, being exposed to all this polluted environment. Maybe that will give some of our people who are interested in advocacy something that they can use to communicate in a way that levels the playing field for all of us. And this is India. You can see that historical monument here. On one of these days, you can't really see anything. And this is the timing couldn't be better because we're on the heels of the first WHO conference on air pollution, and I think it's going to be a fantastic one. I can't wait to join that workshop in 2 days. So in looking at the context for the randomized control intervention that we did in Nigeria, you need to also realize that 70% of the households in Nigeria cook with solid fuel. And urban centers also use kerosene, which I know is used everywhere in Bangladesh, in India, and everywhere, because people think this is actually clean fuel because it's liquid fuel. And in Nigeria, it doesn't come near the numbers in India and China, but any preventable mortality is unacceptable. I think that's the way to look at it. And this picture is very universal. I could impose some of the pictures that I've taken in India or in Bangladesh in terms of women when they're cooking and having their little kids with them. And that's why almost 2/3 of the mortality, preventable mortality that we talk about is actually in children in the 0 to 5-year age group. So this is really not a small problem. It's a really big problem that's getting worse and worse over time because poor people have to also have a livelihood if you don't provide for them. So all the people who are burning their stubble, what are they supposed to do? They want to grow their wheat. So this is the setting. So initial study that we did in Nigeria to try and provide an improved stove that doesn't impose any economic burden on these poor people, that just gave them a new stove that's lined with ceramic. Yes, we were able to improve the indoor air quality from about 1,800, if you look at PM 2.5, to about 125 over 1 year of intervention. But we're still talking about residual level that's about 5 times WHO standard on an ongoing basis. This is not sustainable with good health. And if you look at this graphic from Kirk Smith's work, to look at a dose-response relationship, if you look at the zone here where you're looking at the annual incidence and you're looking at the PM exposure, I mean, in terms of whether it's pneumonia, cardiovascular risk, they're interchangeable. For us to be able to make any significant difference, you can see that how much lower we need to get in terms of the exposure for any intervention that we do to have a meaningful impact. In the original pilot that we did in Nigeria, where we actually were able to improve the indoor air quality, you can see how much farther we were away from being able to actually translate the improvement in indoor air quality to meaningful reduction in any of the health outcomes. So we went out to look for a clean stove. So we decided or stumbled on ethanol, which is actually what rich people, how many of you have boats here? Boats. You mean there are no rich people in this place? Wow. Okay, rich people who have boats, they actually cook with ethanol on their boats, okay, because it burns clean. So we actually decided we were going to use this clean stove, which burns below the WHO standard, as the intervention for the study that we did in Nigeria, with this hypothesis that if we're able to transition people who are cooking with firewood or kerosene to ethanol, that it will lead to a reduction in exposure and also reduce adverse pregnancy outcomes. And the specific questions that we're asking ourselves are, what is the relationship between exposure, pregnancy, and the birth outcome? Can ethanol intervention actually also affect pregnancy? Because preeclampsia and blood pressure changes in pregnancy is one of the biggest causes or contributors to premature, mortality from preeclampsia. We have a session is it today on that? So we will go into that. And we were also interested in whether this would actually reduce personal exposure to and also, lastly, with the participants, use the ethanol. In listening to Professor Sumer, in terms of what people are accustomed to cooking with, they want to use, so you may give them this fancy stove, they may not use it. So we were interested in whether the women were actually going to adopt the stoves and why they would adopt this. So this is what the stove looks like. And you can see this is a really nice looking stove, and these were the control stoves. And in terms of the way this is the city in Nigeria, you can see this is a densely populated city, not too dissimilar to what you see in a place like India or China. What we did was we recruited all of these women during the first trimester of pregnancy. We did personal exposure monitoring where they actually carry these monitors for 72 hours. We threw a GPS monitor in there because we were quite interested in looking at indoor and outdoor exposure because people just don't stay indoors. And if you have high exposure outside, no matter what you do, the exposure indoors may still be quite high. So we were interested in looking at that. And then we looked at the PM 2.5, the mean, and how much time people spent with high levels. And we couldn't really pay much attention to the outcome unless they were using the intervention stove. So we had a temperature probe that allowed us to know whether the groups were actually using the stove. Because if they weren't using them, then all our lofty goals would not be appropriate. So these were the birth outcomes that we were interested in primarily, and this was the secondary outcome measures. So we ended up with about 324 women broken down into two groups, as you could see here. We excluded people who could have another reason to have adverse pregnancy outcome. And this is just to show you when we looked at the two groups, the ethanol, kerosene, or the firewood group, that the randomization was good in that we didn't see much difference between the intervention and the control groups. And this is data from the stove use monitor to show that on the left side of this curve, the intervention group completely adopted the ethanol stove. I need to let you know that the stoves, which cost about $50, was given to them, and they also had ethanol during pregnancy. So the adoption of that stove and the kerosene group and the other group using that was very, very important to demonstrate. Otherwise, the outcomes would not be very meaningful. What did we see? I'm just going to run through this quickly because Apsara is already showing me that time is up. During the raining season, the particulate level was much lower than if you're looking at the dry season. And you could see that if you look at the mean 24-hour, 72-hour exposure, it was lower in the intervention group relative to the, and this is just to capture all of this in one. And you can see that no matter what we looked at in the kerosene group, there was a significant reduction in exposure levels, which we couldn't see in the firewood group because the baseline levels in the firewood group was actually much higher. So it was in the intervention group was higher, so it was really difficult to show any meaningful reduction. In terms of the birth outcomes, the intervention group actually had slightly bigger babies, the ethanol group. They were more likely to be able to take their pregnancy to term. They had less preterm delivery, and then the rate of miscarriages were much, much smaller, even for this small study. And for every 148, there was a 148-gram drop in birth weight, especially in the firewood group, when you related that to the exposure level. Probably what we really didn't pay attention or hadn't anticipated would happen is the significant drop in the diastolic blood pressure in the intervention group without really doing anything, because this is just showing you at entry, for those who don't understand changes that happen during pregnancy, the blood pressure usually drops before it goes up. So you can see the two groups similar at entry, but look at the control group. They had more hypertension at the end of the pregnancy. There was a significant drop in diastolic blood pressure in the intervention group without really doing any other thing. There was also significant drop in exposure-related headaches, chest tightness, and things that you would expect. And for people who participate in research, they actually do get better just by participating in the study. But the difference in terms of the between the group was quite substantial. The other important, I'm almost done, Apsara, because it's in terms of the decisions that those women made. At the end of the study, we gave the same expensive stove to the women who were in the control group, and you can see that they were actually using their own money to buy ethanol for the, so that they could actually continue to benefit from what they perceive as the benefit of the intervention. For those who do behavior research work here, the reasons that we actually were doing this study was totally different from why the women adopted the stoves. The pots and pans were no more black. They didn't smell anymore of smoke. The ease of use, they reduced smoke so that the children could stay with them, and no more smoke-related complaints. And they felt that the stove actually put them in a much higher socioeconomic class because they were the envy of the other neighbors who were around them. So in summary, at least in the context of Nigeria, where you can actually get ethanol from agricultural waste, the ethanol stove reduced personal exposure. It actually, cooking with kerosene was actually a bad contributor to adverse pregnancy outcome, and the benefits of using that intervention are listed here. And then the adoption post-delivery, based on their own perception of the benefit, was high. Clearly, 70% of the exposure was indoors versus 30% being outdoor. And that probably played a damping effect on the benefit, but that we were able to still see benefit was really something that we were quite delighted about. So as we talked earlier, with the improvement in indoor air quality, you need to also know that if the indoor air quality from the LPG, the rural electrification is improved, and the ambient air quality remains high, it may not really drive the health benefits that we see. Studies like this are not usually done without support, so these are the people who provided the support for this, and my team in Nigeria. So I'll stop here so that we can get a panel and hopefully be able to take a few questions that you may have on all the presentations during this session. So thank you.